Hi there, Jenny here to tell you about chemical elements and their position on the periodic table. So here are some pictures of different elements on my left here. We've got platinum and we've got on the right neon in these tubes shaped into the letters N and E for neon symbols. And then down here I have mercury in a thermometer. Thermometers used to be commonly filled with mercury, and you can see it's beaded up because it's actually a liquid at room temperature. So just real quick, what differences do you see among these elements? So a couple things I mentioned, mercury was a liquid, neon here is a gas filling these tubes, and here this is a solid. So their physical states are different at room temperature, so they have different properties. Also, you might notice neon has a different color than these metallic looking elements. In fact, these elements here are called metals. Metals have certain properties, one being shiny. Also, they can be pressed into sheets or made into wires. And they can also conduct electricity or heat. So, if you take a look, neon is not those things. It's not shiny, can't press it into sheets. It doesn't conduct electricity very well. So, neon is what we call a nonmetal. Now there is something in between metals and nonmetals, and they're called semimetals, meaning they have properties, some properties of metals and some properties of nonmetals. So here's an example of that. This is a sample of silicon. You can see it looks like a metal. It's shiny, but it doesn't have all the properties of metals. For example, it's a very poor conductor of electricity. So the reason why silicon is interesting and the reason why we have Silicon Valley is because when silicon is combined with other elements, it can be turned into a semiconductor. And you've probably heard that term semiconductor. That means it can partially conduct electricity or heat. So semiconductor is something that we use in electronic devices a lot because we don't want the full conductivity in metals, but to have more control over the flow of the electrons. So that's why semiconductors and semi-metals can be very important in our everyday lives. Okay, so here's the periodic table. And the cool thing about those elements and any element is that the position that it's in the periodic table tells us a lot about its properties, what it looks like, how it behaves. So for example, let's take a look at platinum. That's the first metal I showed you. And then mercury, which was the liquid one that we used to use in thermometers a lot. So these elements are metals. And if you take a look, nickel, silver, titanium, iron, cobalt, you may have heard of these. These are all metals as well. Gold is over here. So these are all metals. And then potassium, sodium, magnesium, calcium, those are all metals as well. So I know when you eat food and you know there's sodium in it, it doesn't look metallic. That's because it's actually sodium chloride. It's a compound, not an element. So, but if you had pure sodium, it would be metallic. So let's take a look at these. All of these elements over here are metals, and in fact, that's what this little staircase is for. This staircase divides the metal elements from the nonmetal elements. So in yellow here, I'm just going to scribble out all the metals, and just be careful that the hydrogen is not considered a metal. So in recent years, hydrogen has been shown to have some metallic properties when it's at under really extreme conditions. But in terms of our everyday life, hydrogen is a gas at room temperature and it doesn't have those metallic properties. Now these down here, these are also metals because these elements down here actually fit into this little part right here. It's in that part would be expanded, and that's where those two rows of elements would go, and then the rest of the periodic table would keep going. So instead of making it super long, they just shrunk it and put that little chunk down at the bottom. So I'm going to make a little note that all of the elements to the left of this staircase are what we call metals. And then that means all the elements to the right of this staircase are called nonmetals. All right. Now with the nonmetals then, I'll just paint them light green just for now. All right, so here's a periodic table search. Let's scroll to page 54 in your workbook. And in this periodic table search, I want you to use some colored pencils or cross-hatching, different patterns if you don't have different colors. And what we're going to do is mark up this periodic table using a lot of different vocabulary. First, I want you to draw in your demarcation line, which is that staircase that separates our metals from our nonmetals. Let's go ahead and find that. And I'm going to highlight our metals, which are on the left side of the periodic table. I'm going to highlight that with a color. Just use yellow here, since there's a lot of metals. And we don't want to highlight hydrogen, right? So hydrogen's not really much of a metal. And then I also want to do the nonmetals. I'll do that over here. So nonmetals right here. Now metalloids, they're not just all of these elements here, so let's point out, okay, here's boron, okay, there's those two, there's these two, and there's these. So I sort of do 1, 2, 2, 2, okay? And if you're not sure, you can definitely look them up and you can find out which elements they are precisely, but I'm just sort of going to do that one like that, okay? So those are my metalloids or semimetals. All right, now within these, you have what are called periods and groups. In the periodic table, let's look at that word, periodic. That means there's something that repeats, a period monthly, for example. So monthly is a period of time, and then another month, and then another month. So periodic table is referring to the properties of these elements. If you took a string of elements in the periodic table, you just line them all up. This is actually how the periodic table was developed. If you lined up all the elements and then you circled them around, like around a cylinder, you can line them up so that the element in the first row, when you wind it around, in the second row, there's something in common about those, and they line up and down, or in columns. So the columns are important, and the rows are important also, but mainly it's the columns where you can predict certain properties are similar. So the period is referring to that periodicity is referring to that repeating pattern that you go around, and then you go around, and you go around, and that these elements are similar to each other. So period is referring to the row. Let me write that down somewhere for you. Period is referring to the rows of the periodic table. And then the columns, which are important, are what we call groups. And those groups are sometimes called families because they have these similar properties. All right, so now let's take a look at some of these families or groups. So the first group here is called an alkali metal. And these groups are numbered from left to right, group 1, group 2, and then we sort of skip this middle part and we say group 3, group 4, group 5. So you'll see these numbers above the periodic table sometimes, and they have the letter A sometimes as well. So they tend to go 1A, 2A, then jump over here. Sometimes it'll say 13, but sometimes the old system says 4A, 5A, 6A. That's actually more helpful. 7A, 8A, I can't count. Anyway, you know how to count. Okay, so 1 through 8, skipping the middle, this part, skipping that part. So the alkali metals are these elements in the first column, except for hydrogen. So I'm going to use different colors here. Here's, oops. Here's my group 1A, except for hydrogen, and hot pink here. These are my alkali metals. So my alkali metals are things like sodium, lithium, sodium and lithium, and potassium. These elements behave similarly. For example, in water, they will react sometimes violently, even burst into flame. So they have that in common. Hydrogen's not a metal, so it can't be in that family. Sorry, hydrogen. Alkaline earth metals. So I don't know if you've heard of limestone, or definitely probably have heard of marble. These limestone and marble contain calcium. Calcium is right here. A lot of these elements are found in the earth, so they're called alkaline earth metals. Let's take a look at those. Alkaline earth metals are right here. These are in group 2A. So a lot of people have trouble remembering alkali metals versus alkaline earth metals. They both have the word alkali in them. So I remember specifically calcium, limestone, earth. Okay, so that sort of helps a little bit. Noble gases are elements that are not very reactive. So that's why they're called noble, because they're not reactive. They're just very, stable. So noble gases are in this group here on the far right called 8A. And then halogens, you may have heard of halogen lights, halogen lamps. Halogens are next to the noble gases right here. So that's where you get things like chlorine and bromine iodine. The rest of these questions are just sort of orienting you. If we say find an element in group A, 3A, so any element in 3A would be any of the ones in this column right here, this family or group. Identify location of the fourth period. Fourth period would be 1, 2, 3, 4. So fourth period is the fourth row of the periodic table. So any of these elements going across right here. Identify location of the members in group 5A. So 5A, you can see right here, and they want the group, so that group is a column. So here's 5A right here. And the sixth period. So sixth period would be 1, 2, 3, 4, 5, sixth row. There we go, like that. Okay, so that sort of helps you figure out the rows and the columns. Now on the second periodic table, we want to look at the stuff that we didn't look at before, and that was, I didn't tell you about this middle chunk that we were ignoring. This is called the transition elements. So, and sometimes they're called transition metals. It's basically all of these guys in here. And if you remember, there's this special point right here where these all expand from. So these are all compressed into here, and they're called the inner transition elements because they are inside the transition elements location. So I'll put those in blue here. So these guys right here are all squeezed into this little spot right there. So they sort of bleed out. There we go. Okay, so that's where they come from. And the lanthanide series are even a further division. Not so important. You don't hear about it very much, but lanthanides are these elements here, and actinides are these elements here. And we don't hear about them that much, but they do come up now and then. Some of the rare earth elements that we need in our electronic devices and phones and computers, they are actually, some of them could be these guys down here as well as some of these in here. So we hear about them more and more each decade. All right, and then finally, the broadest definition is where we just have these metals here, the transition elements, and then everything else that I haven't colored in, those are called the main group elements. And those are really a lot easier to understand. So we are going to learn a lot about these elements here that we didn't color in. They're called main group elements, sometimes representative elements, but I use the term main group. And then the ones that we did color in, those are called transition. Transition and inner transition. Ugh, my pen is not working. Transition or inner transition elements. So there you have it. It's a lot of terms, right? So main group versus transition. You've got metals, nonmetals, metalloids, alkali metals, alkaline earth metals, noble gases, and halogens. And then you want to just generally know about periods and groups. So a good way to learn these is just to practice. Maybe draw out the periodic table and just try sketching it out and make some flashcards. You know, alkaline earth metal, group 2A, alkali metal, group 1A, metals on the left of the staircase, nonmetals on the right of the staircase, things like that. Groups are columns, rows are periods. So things like that can really help. Good luck, everybody.